All right, guys, let's go ahead and get started on our lesson today, 1.2 linear measure. So our I can statement for today is I can measure segments and I can calculate with measures. So some vocabulary for this. First one we have is a line segment. Okay, so most of you guys have probably heard of a line. So we would know a line would go something like this, right? We'd have, let's say this was J and K. And we have arrows that go on forever and ever, right? And if we wanted to name this line, we would say line J, K, okay? You guys have seen this before, but this is a line segment, okay? So the difference between a line and a line segment is a line with these arrows shows us that it goes on forever and ever. A line segment has these points, okay? It has these points. So I'm going to underline or outline these in red here to show you. To highlight this, they have these points on the end of it, and that's what stops them from going on forever and ever. So let's say this was TS, okay, TS. The way that we would name this line segment here is we would just say TS, and we would put a line over top with no arrows, okay, no arrows. So line has arrows, line segment, no arrows, okay? Congruent segments. Congruent segments are exactly what they sound like. Those are two segments that have the same length. So let's say that both of these segments here had a length of, let's say, 4 centimeters, okay, 4 centimeters. Well, that would mean that these are two congruent segments, okay? All right, moving on. First things up, find the length using the ruler. So we want to use this ruler here to help us find the length of this fish. Now, right off the bat here, I know that this is going to be between 5 and 6. So whatever my answer is here is going to be between 5 and 6. Now, I want to count how many hash marks we have in between 5 and 6. So how many does it take to get from 5 all the way to 6? And it looks like there are 10 hash marks, okay? So whatever we do, we're going to have 5 and then something over 10. Okay, so 5 and something over 10. So let's count these and figure out how many there are. So it looks like 1, 2, 3, 4, 5, 6, 7. So right here, looks like this is going to be 5 and 7 over 10. 7 over 10 also reduces to 0.7. So 5.7 centimeters or 5 7/10 centimeters would work perfectly for this, okay? Both of those would be correct. Moving on now to the next one, we have inches here, okay? So inches are a little bit different than centimeters. Inches are a little bit more difficult to deal with because there's a different amount of hash marks, okay? Centimeters had 10 hash marks, nice and even, makes it really easy for you to just put that into a decimal. Inches are a little bit different. So let's count how many we have here along the way. So it looks like we have about 16 hash marks. Okay, so 16 hash marks. So what we're going to want to do here is I can definitely already see that this is between 1 and 2, right? We know that it's not more than 2, and we know that it's definitely more than 1. So we're going to have 1 and some sort of fraction here. All we're going to do is we're going to count how many hash marks until we get to this dotted line. So looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Okay, so we have 1 and 14 sixteenths. However, anytime you see a fraction that has two even numbers on it, we always can divide that by 2. So since 14 and 16 are both even, we can divide both of those by 2. That's going to give us our final answer here of 1 and 7/8 inches. So because 1 and 14 over 16th was even, we can change that to 1 and 7/8. Okay. Next one here, AZ. So we are looking at AZ. This one here is pretty straightforward. We are doing inches, but it clearly shows us here that this is the halfway mark in between 1 and 2. So we can say here easily that this is going to be 1.5 inches. All right, now for your guys' definition here, the only definition that I really want you to write down is this picture as well as this equation. Okay, this picture and this equation. So go ahead, start writing that down. Pause this right now and start writing it down. And when you return, I'm going to go ahead and start talking about it. Okay, so this definition, this tells me that PM, well, let's look at what PM is. It looks like PM is this segment right here. Okay, PM is this segment right here. If we take PM and we add MQ, so MQ would be the segment right next to it, so this blue segment right here. If we add the red and the blue, that would equal this full segment PQ. Okay, so since both of these segments add up to give us PQ, we can say that PM plus MQ is equal to PQ. All right, now let's say if we did some examples here, and I asked you, if I said, hey, what is, if I said that PM was 3, and I said that MQ was 1, right? So this is 3, this is 1, and I said, well, what's the whole thing? If this part of it is 3 and the other part is 1, what would the whole thing be? Hopefully you're sitting in your seats at home saying 4. Okay, 3 plus 1 is 4. That's exactly what we're looking for, right? Now, likewise, if I said, hey, this whole thing is 20, right? And MQ over here is 5, well, what's PM? So hopefully you're thinking right now about how we could possibly even do that. If we know this whole thing is 20, we know that this is 5, that means that this right here has to be the difference between 20 and 5. So this would have to be 20 minus 5. This would have to be 15. Okay, hopefully that makes sense. We're going to do some examples here that is going to help us along the way. So first up here, go ahead and write down find XZ. And then I want you to draw this picture in here as well. Make sure you draw that picture. Okay. If you need to pause it, go ahead. I'm going to go ahead and get started. So first thing we want to do here is we actually don't want to include any of the numbers yet. What I want to do is I want to focus solely on our line segments. So I want to know what plus what equals what. So it looks like our full segment here is XZ. So I'm going to talk just a little bit about this XY first. Okay, I'm going to take this XY. Now, if I add YZ, so if I take XY plus YZ, then I can see how this is equal to the full thing XZ. Okay, XY plus YZ is equal to the full segment XZ, which is really good. I'm glad we got this so far. What we need to do now is all we need to do is plug in these numbers. So we just need to plug in this for XY and 2.5 for YZ and see what it gives us. So XY is 4 and 5/8. YZ is 2 and 1/2. And that is equal to XZ, which we do not know. So we're just going to leave that as XZ. All right. And now from here, what we need to do is we really just need to add these two numbers together and figure out what XZ is. Okay, so we're going to take 4 and 5/8 plus 2 and 1/2, and that's going to be equal to XZ. So I'm going to go ahead and just jump ahead. If you wanted, you could put these in the calculator to see how to do these fractions. I'm not going to explain that in this video. If you need answers to that, let me know. But I'm just going to go ahead and jump ahead to our answer here. Our answer is 7 and 1/8 is equal to XZ. Okay, 7 and 1/8. All right, moving on. Next question here. We're looking for LM. Looking for LM. We're trying to figure out what LM is, and they give us a bunch of different information here. So let's go ahead and just start off. I don't want to start with any numbers. I want to start with the letters. So I want you to give me what's going on this line segment. What segment plus what segment is equal to the full segment. So I'm just going to start with LM, and the reason I start with that is because that's just the first line that I see. And the next line that I see is MN. Lm plus Mn is equal to, now you want to make sure that when these add up, they're equal to the full segment. So Ln. Okay, so we got Lm plus Mn is equal to Ln. Again, all we have to do from here is plug in. So plug in your known values. Well, we don't know what Lm is, so I'm going to keep it the same. So Lm plus Mn, well, Mn is 2.6. And Ln, the full thing here, is 4. So far we've got Lm plus 2.6 is equal to 4. And if we want to solve this here for Lm, we're just going to treat this like it's an algebra problem. Okay, we're going to say Lm is our present here. We want to unwrap our present, which means we have to undo this plus 2.6. So in order to undo it, I want to subtract it. So we're getting rid of that there. So Lm is going to be equal to 1.4 centimeters. Okay, Lm is equal to 1.4 centimeters. All right, next one up here. Find the value of x and the value of BC if B is between C and D. Okay, find the value of x and BC if B is between C and D. Well, right here, this is telling me we are going to need to draw a picture. Okay, so we can't just do this based off of what we think it looks like in our head. Let's go ahead and draw a picture to help us. So I'm going to draw it going straight up and down. And I notice it says B is between C and D. So B is between C and D. So let's go ahead and put B on here. And if it's between, that means C and D can either be the top or the bottom, doesn't really matter. And they're telling us what all of these are right here in this line. So CB right here, 4x minus 9. BD, 3x plus 5. And CD, the full segment, is 17. Okay? So this gives us a pretty good idea of what's going on in this picture. And we're not going to do this any different than we did the last question. We're going to do this the exact same way that we did the last question. So we're going to start off with some letters that give us a sentence about this line. So I'm going to start with the first line that I see, which is CB right here, and then BD. CB plus BD is equal to our full segment here, CD. Okay, CB plus BD is equal to CD. Now, we're going to do everything we did in the last question. So we're going to plug in all of our known values, which we do actually have values for all three of these. So this is 4x minus 9. BD is 3x plus 5. And CD is 17. Okay, so we have values for all three of them. We plug all three of them in. From here on out, it's just combining like terms. So when we're looking at our like terms here, it looks like we got a 4x and a 3x that can go together. We also have a negative 9 and a positive 5 that could go together. Okay, so let's go ahead, combine our greens here. So 4x and 3x, that gives us 7x. And our blues here, negative 9 and positive 5. When we combine those, that's going to give us a negative 4. Okay, a negative 4. So we're going to be left with 7x minus 4 is equal to 17. All right. And again, from here, now we can just go ahead and identify the present and reverse order here. So let's work backwards to get rid of everything around our 7x. So it looks like we got a minus 4. We're going to need to add 4. And we are almost done, leaving us with 7x is equal to 21. Last step here, divide both sides by 7. We're going to get x is equal to 3. Okay, so x is equal to 3. However, that's not our final answer. That's one of them, so we can go ahead and box that. But up here they say find the value of x and BC. Okay, find the value of x and BC. So now we have to go ahead and plug in our x to BC. So we know that BC is equal to 4x minus 9. All we have left to do now is to plug in our 3. Okay, so the reason I got this 3 here was I put this 3 in for our x because we found out that x is equal to 3. So that's where that 3 comes from. I'm going to do this in 2 steps here. 4 times 3 minus 9. Well, 4 times 3 is 12. And finally here, we have 12 minus 9, which will leave us with 3 as well. Okay, so x is equal to 3, and BC is also equal to 3. Trust me, it will not always work out where BC and x are the same, or the segment that you're looking for and the x are the same. It's rather rare that that does happen. So make sure whenever you find x, you also plug it back in to find whatever segment they're asking. All right, last one here. Okay, last one here. Find the value of x and st if t is between s and u, st is equal to 7x, su is equal to 45, and tu is equal to 5x minus 3. So they've already drawn the picture for you there, but I want to highlight something that I noticed. They said find the value of x and st. Okay, the value of x and st. So we're going to have to make sure we pay attention to that. Now, there's only one thing here that they have not labeled. They have not labeled what the full thing SU is. They did give it to us, so that's where I found it. But they didn't label that on the picture, so I thought that was kind of messed up of them. But we'll throw it in there. All right. Now, let's go ahead and start off this question the way we do with every question. Okay. We are going to use our letters first. So we're going to say UT plus TS. UT was this first line, TS was the second line. That's where I got those. And that's going to be equal to the full segment, which is US. All right. UT plus TS is equal to US. From here, the same thing we've been doing the whole time, just plugging in our values. So UT is 5x minus 3. TS is 7x. And US is 45. Okay. UT plus TS equals US. Well, that really means 5x minus 3 plus 7x equals 45. Okay. Now that we plugged in, almost there. Just got to combine some like terms here and then solve. So 5x and 7x, we're going to combine our reds together here. That's going to give us a nice 12x minus 3 is equal to 45. From here, in order to solve for x, we got to get that 12x by itself. So we're going to go ahead and add a 3 to both sides. Add a 3 to both sides. So we're almost there. 12x is equal to 48. I apologize. I'm getting a little sloppy here at the end. Divide both sides here by 12. And we're going to get that x is equal to 4. Okay. Now, we're not done yet. We highlighted up here. We also have to find st. So we're going to have to plug x back in for st. And we know that st is equal to 7x. And if you're wondering where I found that, it's right here. Okay, st is equal to 7x. All we have left to do is plug in our x is equal to 4. So we're going to plug in that 4. I'm going to draw an arrow here just for anybody that got lost along the ride. Okay, that's where we found that 4. And our final answer is going to be st is equal to 28. All right. So that is our lesson for today. I hope that helps. Check your assignment to see if there's anything due. Have a good one.